Hey, this is Jim from DTRSec. This is the 15th video in the Reversing in REnigma series. We will continue analyzing the executable malware recorded earlier in this series. In this video, we will show you how to use the single-stepping debugger built into the REnigma GUI. Let's do a quick overview of the single-stepping debugger in REnigma. First, we will set an execution breakpoint at an nt create file system call. Then, we will demonstrate single-stepping by showing the CPU transition into the Windows kernel. Next, we will examine the CPU register state in the debugger interface. And finally, we will use one of the CPU registers that contains a memory address to show how to view memory in the debugger. Now, let's take a look at this in the REnigma web interface. First, start on the REnigma homepage. Then, we click on the Recordings tab. Then, we click on the Expand button for the recording we want to examine. And then we click on the Start Paused button. And then we click Replay to launch a new replay of the recording. First, let's scroll down to the Snapshots section. The execution point we have selected for the nt create file call is at event number F8302. Note that we determined this execution point ahead of time using techniques described in previous videos. So let's select the rsnap at F0000 to get the replay close to that point. Then, let's copy in the desired execution breakpoint. Then we click the Set button to tell REnigma to stop at that execution point. Now, let's click Play to allow REnigma to replay up to the desired execution point. Next, we will scroll up to the REnigma debugger interface. And then we will click the single step button to step 1 instruction commit. As you can see, during that single step, the CPU switched into kernel mode. You can tell because the RIP starts with all Fs, which means it is a kernel address. Now, let's take a look at the CPU register state. As you can see, REnigma shows the RIP, the R flags, and all 16 general purpose registers. It also shows the debug registers DR0 through DR7. And on the bottom right, it shows the top of the CPU stack as offsets of the RSP register. And if we click on the R8 register, which contains a virtual address, we can see the View Memory option. When we do that, we can see the contents of the memory at that address. In this case, the R8 register contains the third argument to nt create file, which is a pointer to an object attributes struct. So the memory we are showing is the raw bytes inside of that struct. With the ability to single step, view CPU registers, and view all memory references, REnigma gives you more detail in a malware sandbox than any other product on the market. And that's all for now. If you want to learn more about REnigma or are interested in evaluating REnigma, please visit dtrsec.com. Thank you for watching, and I hope you enjoyed the video.